Now let's try this. At time 14.00 hour, a ship B is sailing on a northeast course at 12 kilometers per hour. When it sights another ship A at a position 10 kilometers north 60 degrees east, which is sailing on an east-west course at 15 kilometers per hour. Ship B continues on its course until ship A is directly ahead it. It then changes course in order to rendezvous with ship A as soon as possible. A. Determine the time at which B changes course and its distance from A at that time. B. The new course taken by B. C. The time at which the two ships meet. Plot the path of B relative to A and verify that the time taken by B to traverse this relative path agrees with the time determined in C above. Disregard the curvature of the surface of the earth. Now we are told at 14:00 B is sailing on the northeast, that is this, 12 kilometers per hour. When it sights another ship A at position 10 kilometers north 60 degrees east, so this is 60 degrees, north 60 degrees east, and that is 10 kilometers. This is A, which is sailing on a east-west, is going like this at 15 kilometers per hour. Ship B continues on its course until ship A is directly ahead. That is, it continues here until it views A here. Let's see. So it sees A, not that it crosses to this place. When it gets to a point, it saw A. Ship B continues on its course until it then changes course in order to rendezvous with A as soon as possible. That is, after getting here, it changes course. It changes to come and meet A at this place. Now, it now says, determine the time at which B changes course and its distance from A at that time. Now, if we are going to use construction method, it is very easy. Let's work on the first part. If we are going to use construction, we draw to scale to locate the position of A and B relative to each other. That is, this is A, this is A, this is B. 10 kilometers apart. And this angle here will be 30 degrees. Because we have known that that is 60 degrees. So you will draw this to scale. And then we will now draw for the path of B, because this one is 45 degrees. We draw 45 degrees line to go straight, just like when we do normally locus to locate some points. Draw the path of B. So the path of A to cross B at 81, that is this place. B is coming like this. So we have not put B, for now we are not considering the velocity or anything. What we are just considering about is the path that normally they ought to take. So when you now measure A to this place, because this is the point where B will view A on its motion and changes its course. So at this point, this is the point, and the distance traveled by A at that point we can get from our measurement. So what we get from this measurement now, we will now divide it by 15. That is the time taken from here to this place for B to view A directly. The distance traveled by B at that time will also be 12 times this time, T1, that is AA T1 over 15. So that is the distance traveled by B. You will locate that one too. Measure and locate. You will now measure the remaining distance. This is B, this is B T1. Yeah. So you now measure this place. This is the distance between B and A at that time that B views A ahead. That is very simple and straightforward. But if it is for calculation, let me show you what to do. Now, if you have to follow calculation, look at this. Look at how it will be relative to each other. Initially, B was here, A was here. And look at the path crosses here. So by calculation, we realize that this place is 10 sin 30, and this place are the same thing. This place is also 10 sin 30. And we have 45 degrees here. So automatically, tan 45 is 1. This place is also 10 sin 30. This whole place is 10 cos 30. Then, we now see that 81 to A is 10 cos 30 minus 10 sin 30. 10 cos 30 minus 10 sin 30. So, we now realize that T1 will be this distance over 15. And that is what we calculated. length of BBT1, that is B to the time it will change its course, or the time it will view A ahead, is going to be 12 times this time, and that is 2.928. That is the distance it will move up this place is 2.928. So length of this place to this place, that is the distance apart from the two of them at that time, is going to be this distance minus this place. So it was calculated by BAT1 minus BBT1. So BAT1 is 7.071, BBT1 is 2.928. So BT1 to AT1 is 7.071 minus 2.928. That gives 4.143 kilometers. So either way, you will get your answer perfectly. You can also go through it using vector. Vector is also similar to this one. So for this first part, there is nothing much. The only thing that you need to know or do is just about the intersection of these two lines and the knowledge of straight line equation. Now to get the point of intersection and the point at which it will view the shape A. This is B. So this is our reference point, you know. So, and A is here. You have said this place. You have said this place to be 60 here, and this place too 60, and yeah, 60. Then, with respect to this place, we have this place to be, and that is B, 10 cos 30, 10 sine 30. And we have this one, it's moving. The angle is 45 degrees. So what is tan 45? Is equal to 1. So which means our equation for this line. So for line 1, y is equal to x. For line 2, here, line 2, our y, it is a constant line. So it is a straight line parallel to the horizontal axis. So we have it to be y equals to 10 sine 30. Therefore, the two of them will meet here. Yeah, y equals to y. So let's find x and y. So x will be equal to 10 sine 30. And then, since y equals to x, y will also be equal to 10 sine 30. So this place, that is the intersection here. So you have 10 sine 30, 10 sine 30. So that is what we have here, BT. So it gives us easy, that's the way to locate the point at which B, okay, this place is A, sorry, A. So A, so this is B. So the point at which B will see A is this place. This is where A will be. That's where A will be. So B is moving 45 degrees. A is moving parallel to the horizontal, at least on our plane of reference. So that's the easy way to locate it using vector analysis. Solve that one straightforward. So let's quickly go to the second part. Now, this is the relative position now for the second part of the journey. I rather will restrict ourselves to this and forget about the first part. This is the diagram for the next one. So we are asked to calculate the time they will rendezvous, meet together. We know this one to be 12, we know this one to be 15. And we have said it that for them to get together, at the end of the day, that the distance between them will be 0. That is the minimum distance between them. It will be 0. The relative velocity must pass through this same place, must pass through this bearing between the two of them. Now let's see how we do the construction. So we place this relative velocity part to be here, and that is 45 degrees. Then we will say we have 15. Okay, let's make this one stagnant now. We have 15 kilometers per hour. So we now draw the 12 by putting our compass here. We put our compass in this place. we will measure 12 on the compass. We will put it here and then we let it cross this place. So this will be 12 kilometers per hour. You know, everything is to scale. So the measurement of this place to this place will be our relative velocity. And you see, the relative velocity is now downwards. We have this place to be 45 degrees. So we can find this direction. We know this place to be 45 degrees as well. That is how you draw it. The main thing you need to do is just make sure that the relative velocity coincides with the path of the bearing. That is all. So you will now, for us to now find the full time, it will now be this distance apart, BA over relative velocity, which is 4.143 over whatever we get at this point. I believe that is clear. If you want to use calculation, now, all we need to do is this. We have this place to be 45. We have this place to be 12. This place is theta. Yes, you measure this place as well. So you measure theta. And the answer you get it. So the new direction will be, new direction will be equal to theta plus 45 degrees. And if it is greater than 90, you subtract 90. If it is less than 90, you know what to do. So that will give you your direction, either east, northeast, or northwest. That's how you get it. But from the horizontal to this side, this is the total direction. Now, if you have to use calculation, since the first thing also is to get relative velocity. This place is 45. I don't know this place, but you can use sine rule by first of all getting this place. That will be sine theta over 15 is equal to sine 45 over 12. So theta will be equal to, now I don't want to inundate us with the calculation, so I decided to use sine rule, and so sine this over this is equal to sine this over this. So I was able to get this direction. The other angle, that is this one, which relative velocity we face, is 72.89. I got that one. So to find the relative velocity now, I use sine rule to find the relative velocity straightforward. I got 16.22. From there, I have gotten initial time from this place to this place now. It's going to be this relative distance over relative velocity. And I got 4.143 over 16.22. I was able to get that time too. So total time to rendezvous is this time plus the initial time it took from here to here. And that is 0.4994, approximately 30 minutes. So time of rendezvous, as in for them to meet together, is going to be 1300 hours. If I have to use vector analysis, we can do it in two ways, as I said before. We can use it along the path, along the bearing, or you do it on the normal x and y axis. So the components will be on the relative to the bearing between the 2 points. Or if we do it along the normal x and y axis, it will be along the normal horizontal axis. So let's start with, if we use the bearing, the direction between the two lines as our horizontal. So it will be like this. And this will be 4.143 kilometers. So we know that this one is 12 kilometers per hour. And this one, by the time you look at it, you see it is 15 kilometers per hour, 45 degrees. This one we do not know the theta, we do not know it. Look at this. For them to meet, the velocity, the relative velocity. Now let's work out what that relative velocity will be. And what that shows is that there would be the vertical component, that is the component perpendicular to the path, will be 0. The component perpendicular to this path will be 0. So we are going to have only horizontal components now. That's what it means. And how do we go about that? Let's work it out. BA is equal to 4.143i. That's it. Let's now look at it. VB is equal to 12 cos theta plus 12 sine theta j. VA is equal to minus 15 cos 45 plus 15 sine 45 j. So this is what we have. VA, VB. So VB minus VA, that is the relative velocity. This is what it gives. But we have said that for them to intersect, the path of the relative velocity should be along this VA. And that's, what does that give? Oh. So, and what does that give? It gives this. We have said that, which means that this vertical component, this j component will be 0. Therefore, 12 sine theta will be equal to 10.6i. So, theta 10.61 over 12. So what does that give? 62.15 degrees. So which means that the direction of the B should be 62.15 to BA. So which means that this place will now be 62.15. And as we have discovered initially, so this will now be, let's see what the real direction will be. The real direction of B will now be 62.15 45. So it's going to be, let's see what it will be like. 17.15 degrees north west. Not 17.15 degrees west. So that is the direction that B should go. Straight. I believe we got it in the other one too. 17.15 degrees northwest, not 17.15 degrees west. Now, to find the time, you know we are calculating T2 now. T2. To find T2 now, we are going to divide this, the velocity now. We are using our position, our BA, to divide our BVA. Since they are on the same path, it will be very easy for us to divide. This one has already become 0 already. We are free with that. So it's going to be, so T2 will be BA over BVA. And that is equal to 4.143. Sorry, this is 4.143 divided by 12 cos 62.15 plus 10.61. And what does that give us? So you can see it is 4.143 over this. And then it just gives me the time, straight and direct. Very easy, very straight and direct. So in this instance too, we can also consider plotting the position by which they move. Now, this is what happens. SB, initial position of B is 0, 0. SA, 4.143 cos 45 degrees. I plus 4.143 sin 45 degrees J. So BSA, that is the distance between these two, SA minus SB, is 4.143, the same thing. So this is what it becomes. 2.93I plus 2.93J. VA is minus 15I plus 0J. Please, it's minus. VB is, that is this one. Since you do not know the direction, we are trying to get the direction. 12 cos theta I plus 12 sin theta J. VA minus VB, that is the difference. Relative velocity is going to be the difference between these two. So I got this. Minus this, minus this. This one is minus this. This one should be minus. This one should be minus. So for rendezvous, for the two of them to come in contact, I realize that they must be parallel. And for them to be parallel, the cross product, I mean the relative velocity and the displacement between the two of them, they must be parallel. And for that to happen, the cross product will be 0. The cross product will be 0. So I have minus 15 minus 12 cos theta cross this one minus this. So this one should be plus here. So minus this, because this one, oh sorry, minus this. So this one will be minus. This one should be minus. So the cross product will now be minus 15 minus 12 cos theta times this 2.93. And this one and this one. So we are going to have minus 12 sine theta dot 2.93. This will give us 0. That will give us 0. So let me work it out. So we have gotten to this part. At the end of the day, we resolve this using the identity. And theta was 72.89 or 180 minus 72.89. But for this equation to be possible, it must happen in the second quadrant, where cos theta is negative. So that is 107.11 degrees. So the direction is not 17.11 degrees west. That is the direction. Let us now work out the time. So since we have gotten the direction now, we can work out the time by which they meet. And this is the distance divided by the relative velocity. And this is what we got. Straight answer. So total time is this. And time of rendezvous is 1430 hours. 1430 hours. If we are to consider the actual path, not using relative velocity, this is what will happen. So it will be after time, because the movement must bring them together at the same point. This one is 0, 0, and this one is like we got sine. So for A, B is 0, 0. A is 45i plus 4.143 sine 45j. So that is the position of A at the beginning of the journey at T. So VB is 15 minus 15. VA is 12 sine 12 cos theta I plus 12 sine theta j. That is for the velocity. So position of A, let's start. Position of B at time t, at any time t, is going to be so VA, velocity of A is minus 15i or 0j. VB is 12 cos theta I plus 12 sine theta j. And we know that when they rendezvous, the two of them, their position will be the same. I component must be 0 as in the difference, and that of j should be 0. So let's see. Position of B at time t. This is at time t equals 0. At any time is going to be, so SB will be equal to 12 t cos theta plus 12 t sine theta j. SA will be equal to this one 2.93 I plus 2.93 j. SA is going to be 2.93 I minus 15t. Let's make it 2.93 minus 15t I plus 2.93 j. For B, we have got to the 2 now. So at rendezvous, SA minus SB will be 0. That is, I component will be equal to J component, which should be us 0. So now let's look at it. It means that 2.93 minus 15t minus 12t cos theta I plus 2.93 minus 12t sine theta will be equal to 0. Will be equal to 0. So What will happen now is this. We now equate this one to be 0. So 2.93, that is the j component, minus is equal to 12t sine theta. And this other one, we have 2.93 will be equal to 15 plus 12 cos theta t. Let's make this 1, let's make this 2. So t will be equal to 2.93 over 12 sine theta. Now, let's substitute this in equation 2. So I have 2.93 is equal to 2.93 over 12 sine theta into 15 plus 12 cos theta. So that will give us 12 sine theta is equal to 15 plus 12 cos theta. So we are going to have sine theta minus cos theta equals to 1.25. And we have solved that one. So that is how you go about it. So we have been able to solve that. And if you want to look at it from, like, this place is 4.143. That is, you want to look at it along the path BA. So what will this one be? 12 theta. This one is 15. 45. So all you just need to do is to say, okay, this is the distance along the horizontal, this is the distance along the perpendicular. But one thing is sure, on the perpendicular, the two of them must travel the same height. They might not travel the same on the horizontal. Let's look at what that one will be like. So you can see, the initial position of B is 0, 0. For A, 4.143 and 0. B, the velocity of B, 12 cos theta I plus 12 sin theta j. Velocity of A, 15 minus 15 cos 45 degrees plus 15 sin 45 degrees. So position of B at any time is 12 cos theta I plus 12 sin theta j. Position of A is this one plus this one times time. So I have this one, 4.143 minus 15t cos theta cos 45 I plus 15t sin 45 j. So at rendezvous, this difference will be 0. So now, BB is this. At any point, we have said it. So which means that along the I, the distance will be 0. Along the X, the distance will be 0. Therefore, 15t sin 45 is equal to 12t sin theta. You know this theta does not include the 45 degrees. Does not include this 45 degrees. So when we get this theta, we have to have that 45 degrees to get the actual direction. So t cancels t. So we have sin theta is equal to 15 over 12 sin 45. So from here we can get our theta, and I think we got 62.11. So the actual direction now is equal to 62.11 plus 45, which is 107.11 degrees. So it is going to want to be like this, 107.11 degrees. So you can see, I have shown you all the, at least I might not say all, but at least with this, you can tackle any problem. And I've given you full explanation about this. If there is any question, you can contact me through the mail or the comment section. So from here, we can come back to get the time. You can come back to get the time. And how do we do that? We can put the time here. We can put the time in the first equation. So we can now say 4.143 is equal to 15 cos 45 minus 12 cos plus 12 cos 107.11 all into t times t. So t, we can find our t now. This the initial one too. Just substitute t in the place where it should be. Let's work that out. Now to find our t, we substitute this one here because this is the one we found. That is our theta. This is our theta. So we substitute it in the I portion. In the I portion. And that will give us 4.143 is equal to 15 cos 45 plus 12 cos 62.11 all times t. So t will be equal to 4.143 over 15 cos 45 plus 12 cos 62.11. Let's see what that is. So now, this is the calculation for t. 4.143 over this, and I got this one to be 16.22. So you can see everything, either way you go about it, you get the right answer. You might be compelled to use a technique in your assignment or whatever, or you might just feel like, okay, this is the one that I have flair for. So I have given you all this. Go ahead and play with it. Now, let's calculate the velocity of B relative to A. So B is this. B goes like this. 12 kilometers per hour. A goes like this normally. So now, we direct it like this. So we have 15. We know the angle here is 45. So this is our relative velocity, B. So what happens now is this. This is 135. We can calculate this, and we can calculate the direction of our relative velocity now. Let's see. Normally, if you have used construction, all this will be, I won't need to do all this calculation. You get everything from your construction, right from the relative velocity to the direction. So the relative velocity is equal to 24.97 approximately 25, and this angle here, alpha, because this place is 135, please. That is 135 degrees. So this place is approximately 25.1 degrees. So here is, everything here is 45 degrees. So this place is approximately 20 degrees. So the relative velocity will move here is approximately 25.1 degrees. So here, down here, is approximately 20 degrees. Approximately 20 degrees. So the relative velocity will move 20 degrees to the horizontal for some time and then stop. And it will move with time of 366 divided by 15, the one that we calculated there. So from there, it will now move parallel to the path, to this place, to join A there. So let's calculate. From here to here now, if you have 24.97, and it moves like nearly, let's say 19.9 degrees. Let's move it. And that will be 24.97. And the velocity is, that's 24.97 kilometers per hour times 0.366 over 15. That is what this place will be. And this place will be approximately 20, or let's say 19.9 degrees. That is what we will have there. And then we will have the other relative velocity we got along this place. And that value is, and the relative velocity here, that is along this path, later on was 16.11. 16.11. So if we plotted it, if we had used construction, we will get it straight. But because we are calculating, let's verify. So this place to this place now. So now, sorry, this one is 16.22. So if we calculate this one now, we are going to get place. It's going to be 24.97 times 3.66 divided by 15. You know this is the time. And our answer is approximately 6.1. So it moves 6.1, 19 degrees to the horizontal. And then it now moved. We got this place to be 0.244. Let's calculate 3.9. Let's say 3.96. 3.96. So for us to really know that it covers this place, when we calculate the horizontal component, it's supposed to give us 10 cos 30. When we calculate the vertical component, it's supposed to give us 10 sin 30. Let's see how that works out. And from our calculation, the last part, we got it to be 4.143. That is the part here. 4.143. Now let's calculate this. We have 4.143 4.143 cos 45. Let's verify. Oh. So this one too, vertical is equal to 10 sine 30, which is 6.1 sine 19.9 plus 4.143 sine 45. Let's confirm. So that is our answer. You can see the approximate answers. So our timing, ordinarily if it is by, what's it called? Construction. All you just need to do is draw a line straight from here, 45 degrees. And you draw another line, 19.9 or 20 degrees. And if you cross like this, so you get your answer straight from there. And you just divide this one by the relative velocity here. You must have gotten from the diagram. And you divide this one too by the relative velocity gotten from the diagram. So you prove your answers. I believe that is clear. You know how we got the relative velocity through our construction initially. You know where we got this one too. So if you want to get this distance by construction, just draw 45 degrees line down here, because it is 45 degrees here, 45 degrees there. Draw line 19 degrees to the horizontal here. So it will cross here, and that is how you get your answer. Thank you very much.